Section 4.2, paths. Talking's hard. Circuits, Euler paths, and Euler circuits first off. Euler. That's a guy's name, Leonhard Euler, famous mathematician. You see his name in a lot of things. He even has his own number, E, but it's pronounced Euler, not Euler. This has the same rules as Beetlejuice. If you say it wrong 3 times, he comes to visit you at night. You don't want that. He will make you do math problems. It's terrible. A path in a graph is a sequence of adjacent vertices and the edges connecting them. Now that's part of the definition. There's more to come. In a path, a vertex may be visited more than once. However, an edge cannot be reused. So once you go from A to B, the edge you crossed over, you can't cross back ever again. So be careful with that. So a sequence of adjacent vertices and the edges connecting them, where you can't reuse an edge. That's the definition of a path. Let's do some examples of paths. For instance, let's suppose we parachuted into A and we want to B and to C. You can put commas if you want to. And then to F. So that's a path. There's no set rule on how far you have to travel on a path. We want A, B, C, F, call it a day. I could have wanted something more exciting. I could have taken the loop on C. I could have went to F and then to E and then to A and then to B and then back to C. Notice if I want C to C, so I took this, C to F, down, F to E, E to A to B, B to C. That's it. That works. That's fine. We started where we ended. When you start when you end, that gets a special name later on. I could have had an even more exciting one. I could have went D to E, E to A, to B, to C, to F, to E, to C. Let's trace that one out. D to E, E to A to B, B to C, up, C go around, F, E, C. So notice in that one, I happen to use all of the edges, and that gets an even different name later on. So again, for paths, there is no set length you have to go. You can go as low as small as you want. You can just say AB. Done. That's a path. Or you could try to use all the edges. That's a path. It's a special path. It gets a name later on. But again, no set rules as long as you do not reuse an edge. For instance, if I had done, let me change the color real quick. Red. If I had done, let's see, B, C, E, F, C, E. That is not a path because B, C, right here, C, E, E, F, F, C, and then notice I'm trying to use C, E again. You can't use C again because I already used that edge. That'd be bad. So that is not a path. Anytime where you try to reuse an edge, or if you try to, and let me erase this real quick. Boop, boop. If you try to use an edge that's not there, so if I said A, E, D, A, there is no edge between A and D. Does not exist. Sad face. So don't put an edge that's not there. That's also not a path. If you would, watch the video Finding Paths again. We're going to start to build like a little hierarchy here because basically a path is the biggest thing, most important thing you can have, and a concept of a path carries on in this section and the next one. So when I was going through the examples of paths in purple here, and I said these are going to get different names later, that's what I mean by that. But for right now, watch the video Finding Paths